OK。不好意思，就是这边要投影上去，好像没有那么快。好，那先跟大家讲一下，就是大家应该有在我们的 Facebook 上看到习题，就是练习题。那练习题其实就请大家都回去做，然后我们会有小考，对不对哈？就从那边出，好吗？那4月2号，也就是下的礼拜的这时候，星期二，OK，我们会出2题左右，然后应该就是40分钟，然后1题20分钟感觉，然后做完以后我们就继续上课，OK，所以4月2号2个礼拜后，就下个礼拜，再下个礼拜的这时候，OK，so we will have an exam, quiz, 2 problems from our practice examples. We announced in our Facebook account, club that we have several problems in the textbooks, and please just fix them, and then you can, and all the quiz will be from that list. All right. 好，无法无印的感觉。嗯哼。不知道为什么连不上我的 NYCU，本来这边却可以。为什么我的网络会这么的难以连上呢？上次好像也是这样子。嗯，对不起。呃，请问有没有 Type C 啊？Type C 2头都是 Type C 的线，我试试看，如果有的话，我可以试试看，就是连接直接点。哎，谢谢。2头都是 Type C，耶，谢谢。试试看有没有办法，感谢你。好像 OK 了。如果不行，我就使用线。正在转，哦，可以了，可以了，太好了，那就感谢你。如果你还有之前的话，好，感谢感谢。那我们就开始吧。啊，真是浪费了很多时间呢。来，上一次，sorry，last time we talked about how to the practice. Okay, the problem is that we have a sleeve and bolt. Okay, and constrained by a bolt head, and then we give the delta T change, temperature change, and then alpha S is greater than alpha B, okay? And which means that the sleeve will stretch longer than the bolt itself. So imagine that we don't have that bolt head. We will have delta 1 and delta 2. Of course, delta 1 is greater than delta 2. And then because the bolt head was there, so it would force the sleeve, and the bolt has the same elongation. So it must have some position in between delta 1 and delta 2. Okay, this is the position. And the difference between delta 1 and 3, delta 1 and the final delta will be delta 3. And the delta S with the final delta will be delta 4. Okay, so delta 1, of course, is after the heat up. Okay, delta 2, heat up. And delta 3 means that the bolt head will push it back to the position. So PS will push that delta 3, PSL, ESAS. Okay, delta 4 is another PB, PBL divided by AB, EBAB. And delta 3 and delta 4 here, I give absolute value, means that we just focus on the absolute value, because we know that which one is compression and tension. Okay, so equation of compatibility. Delta 1 equal to, the delta is the final delta, right? Delta is final delta. Yeah, why not? We'll just write down here. The delta okay, the delta means delta 1 minus, sorry, it's wrong. Hey, yeah, okay. Delta equal to delta 1 minus delta 3, and delta equal to delta 2 plus delta 4, right? So, and then we can straight substitute all this information, relationship, constitutive relationship. Sorry, why it become like this? Why it jumped so many pages? Okay, so that's it. Let's take a look. Alpha S delta T L minus PSL divided by ESAS equal to alpha B delta T L plus PBL EBAB. Okay, so I will give the name the first equation. Okay, and the B is equation of equilibrium. Okay, easy. PS equal to PB, because there are only two loads here, two force here. So two. So from okay, from sorry, based on equation 1 and 2. Okay, PS equal to PB equal to, well, alpha S minus alpha B delta T ESAS EBAB and ESAS plus EBAB. Okay, and then we can say, so that we are ready for solving problem 1. Sigma S and sigma B. Sigma S, easy. Sigma S equal to PS divided by AS. Sigma B equal to PB divided by AB. So this is really easy, and I want to copy all this and then divide by AS. So I just, okay, perfect, right? And you know the rest. Dang, 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 dang. So I don't want to write it. And the second problem is that increase delta in the length. Delta equal to alpha B delta TL plus PBL EABA. EBAB, sorry, EBA, EBAB. Okay, so all you need to do is substitute PB into here and delta is the, okay, so all the well, you can the delta equal to this one, right? So you can get this one, and you can substitute all this into this value, and then you can obtain the final expression of delta. So I won't calculate that for you. You can just try it back home. Okay, so that's easy. All you need to do is just imagine that there's no constraint first, and then you put it back. And then put it back means that the bolt head will give the force on the system. Okay, and then the final result need to be satisfy your compatibility. And then you can just make it, write it down. Okay. Right. So statically indeterminate system, 静不定 in system, is all related to thermal condition. Okay, which is heat up, and then you can generate thermal stress. Okay, because some in the most case, because of the extra constraint, so it will make the displacement or deformation is limited. Okay, so it will introduce compatibility equation. Okay, so I hope you can practice more, because all this problem is really complicated. It require you do the practice. And the next idea, okay, after this, we will introduce new thing, stress element. And I believe this is really important for students in material science engineering. Okay, next stress element idea, next idea. Okay, stress element. This is really important, and it can help you to understand how force, how stress in the material. Okay. 我发现用英文讲课会拖得比较长，呃，好像有点赶。以前中文讲就刚刚好，那现在英文讲就发现讲比较久一点，我可能中文讲会讲快，但是英文的话我就会慢慢的讲，可能一题可能就会变成1.5倍了的长度。Okay, it's just saying that the English slow down my teaching progress. I don't know if it is good or bad. Maybe if I speak in Chinese, it was too fast for students in general. But if I take my time, maybe it help you to understand better. I don't know. Maybe you can do the experiment, do the statistic in the end of term, maybe questionnaire. Right. Next one is stress element. Very important. Very important. Stress element is a tiny element in the component, in the material. Okay, tiny element, which is kind of, you can imagine that which is the most effective way to express internal stress. Okay, internal stress. And we can assume that the stress element is infinitesimally small, 无限小. Okay, so when you have this, sorry, force P, okay, and remember that if we cut it in the middle, which means that we have a uniform loading, just like uniform flow, right? Remember I talked about this uniform because it is far away from the concentration load, so it kind of make it the force flow uniformly. So you can see here, and sigma x be equal to P divided by A. Now I give the x here. Did you notice that? X means that the actual symmetry, actual direction, okay? Actual direction, x. So sigma x. So now you notice that now I want to talk about other stress on other direction, not only x. So now I give the name sigma x. Is that what we taught in the first chapter? Okay, and then sigma s equal to P divided by A. What we learned in the chapter 1 so far is sigma x. Okay, now we're going to talk about other direction. So elements, stress element must have some surface, right? Surface. So actually what we learn, typically we just talk about the surface, the stress on that surface, on that direction. Okay, so what we learn is this direction. Okay, and however we have other surface to talk about. So now what is other direction? We can have stress on inclined section. Actually, the section, although we talk about the section like oblique or inclined, 斜的, okay, with the theta. Actually, this theta can vary from 0 to 360. Okay, so this is kind of, we just write down a we use symbol x or theta to calculate this. So the theta can be any value. Okay, this is general, 一般化的. Okay, not only just for specific value. The theta can be 0 to 360 degree. Okay, so now let's talk about the stress in inclined section. And previously we said the stress element we plot here is a typical square. But now we are talking about if we plot the square in this direction, what will it be? We want to talk about the stress on that surface. So that surface follow a new axis called x1 and y1. So now we have xy axis. Now we have x1, y1 x. Previously we have xy. Now we have x1, y1. And we want to calculate the component of the stress, 分量, okay? So now let's take a look here. So we can imagine that if we cut that surface, we will have, of course, we will have something like that, right? And we can change, we can plot the force with two components. The first one is N, the other is V. Okay, what is M? Normal. V is shear. Okay, so your force P can be decomposed to two components, 两个分量 normal and shear. The shear, of course, it is parallel to the surface. N is normal to the surface, perpendicular to the surface. Okay? I guess this is not very difficult for you. So you can see that this is this one we call sigma theta. Okay? And the other direction is this is how the shear stress on that surface. So now the M here, M, V, N equal to P cosine theta, P sine theta. Of course, you see that this X1 and X has the angle theta. So your N here will be P cosine theta. V will be P sine theta. Okay? And then P cosine theta is N. V is P sine theta. And we need to divide that area, right? The area here is A1, not A, because your A is this one. Your A1 is that one. Obviously, A1 is greater than A, right? Here, you can see that if this is BH is the height and width, the A must be B times H, right? However, you have the oblique or inclined 斜的 section. Okay, the cross section area A1, you have the same B, but you will have longer height. The height must be H divided by cosine theta. So your A1 equal to A divided by cosine theta. So the A1 is greater than A. Okay, so your sigma theta equal to M divided by A1. Tau theta equal to V divided by A1. And you see minus sign. Wow, this is really, really, you need to be really careful about this. Why? Because your P is positive, but when you are, and theta is kind of using the anti-clockwise, also the positive direction. So positive direction, you can see everything is positive, but it will introduce a downward shear. The downward shear, see, this is positive x1 direction surface, but your direction is negative v1 axis direction. So your tau must be minus. So you need to be really careful about this. Okay. So when you have all the positive direction, positive assumption, it will automatically introduce the shear in the negative sign. Okay. So minus sign. Don't forget this. So now your sigma theta and tau theta equal to this one and that one. Of course, your cosine theta will right. You can see sigma x equal to P divided by A. So this one can be substitute by sigma x. So sigma x, and cosine theta square equal to this one, and sine theta equal to this one. This is kind of how to say that 背角公式 double angle equation. I don't know how to translate that, but it is a sine cosine relationship you learn that in senior high school, right? So you can replace this into sigma theta equal to sigma x times cosine 2 theta. Tau theta equal to minus sigma x sine theta cosine theta. So I will say this is really important. Okay, so now, no matter how large the value, any value of the theta, you just substitute this, and then you can have the component of the sigma x on that section, on that inclined sections. Okay, so this is how the equation tell you how to help you to determine the any section with the different angles, any cross section in this material. You can be here, 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 any direction. Okay, the component can be determined. Okay, so I would suggest you to memorize it, but you still need to know how to do that, how to prove that, how to show that. Okay, so now you can notice that this is a cosine sign, so it must have the 极值叫做 maxima and minima. Okay, it must have maxima and minima. So let's examine the maxima and minima of that component. Next one, maxima normal stress and shear stresses. Okay, so normal stress, shear stress looks like this. We just wrote the stars on it, and then you see the cosine 2 theta, sine 2 theta. Cosine 2 theta has its maxima at theta equal to 0 and 180. So we make it cosine 2 theta become maxima. So you see, it will be 1. So 1 plus 1 times divided by 2. Oh, sigma theta, maxima sigma theta is sigma x itself. Okay, so sigma theta, when theta equal to 0 degree or 180 degree, it will make it maxima and equal to sigma x itself. Yeah, of course, your sigma theta equal to 0. It is sigma x, right? What is 180? The other direction, right? So totally makes sense, right? And sine 2 theta is maxima with theta equal to plus and minus 45 degree. So the maxima value of the shear stress is sigma tau theta equal to sigma x divided by 2. Okay, right. So theta equal to 45 equal to plus and minus 45 degree, and you will have sigma x divided by 2. The reason why I say absolute value is because that is relatively difficult to determine the shear force direction. We need to see, oh, this is a positive surface and then positive direction, and then you need more time to procedure to determine the plus or minus. So here we just say, okay, maxima absolute value, and then you can determine later. Okay, so let me draw the meaning of this. So now you have P, and element A is here is theta equal to 0 degree, and this direction is theta equal to 180 degree. So you notice that when you draw a surface, a stress element, actually you talk about one of the surface. This surface, it means the theta equal to 0. The focus, our focus, 主角, okay, for our focus is for this is sigma equal to 0. But for that surface, our focus is now on this one, theta equal to 180 degree. So of course, this surface, this stress element has 4 surface, okay? And you can, of course, you can substitute this is 90 degree. This is 270 degree. And you can substitute that and you find that this is 0, okay? So the equations here is kind of magic, okay? Very, very smart. You can try that, you can test that. Always correct. Okay. Now you can see that's what I'm talking about here. Sigma x, sigma y, sorry, sigma x, and 90 degree, nothing. And 270 degree, nothing. Okay, 不好看。Nothing here. Okay, and you substitute 90 degree or 270 degree, it will give you 0 component. Okay, very smart. And then if you have the theta equal to 45 degree, you can obtain this one, maxima, tau maxima, sigma x divided by 2. And interestingly, if you substitute the theta equal to 45 degree, you can still get the normal stress. This is not 0, okay? So sigma theta in at theta equal to 45 degree, this is not 0. It's also equal to sigma x divided by 2, okay? And this one is 45 degree plus 90. So 135 degree, if you substitute the theta into the 2 equation, you can obtain another set, okay? And 135 degree plus 90 again, you can obtain this one. And minus 45 degree, you can get this one. Okay, so you can notice that four main surfaces. This one, 45 degree. This one, 135 degree. This one, 135 degree plus 90. Okay, and this one is minus 45. Each of them substitute these 2 equations. You can get the components here, and you will find that, yeah, their shear stress does. Their shear stresses do come as pairs, come as group 成对出现. Okay, this is really interesting. They just when you study this in systematically, follow the rule, everything match in the end. That's really smart. 总之就是说这个 stress element 应力元素，它有4个面，4个面，每一个面都可以当做主角面。什么叫主角面？就是例如说，我觉得这是主角面，我看它上面的 sigma theta 跟 tau theta 的时候，我这边我就带 theta 等于90度，然后就带进去，然后就发现是0两个都0，两个都0这样。OK， 那这边也是一样，所以你带45度、带135度都可以分别的算出来。OK， 分别算出来，然后你就发现把图画出来，画上去，发现还真的是 shear stress 都是成对出现的，而且值都会是一样，很有趣。那也就是说，这个式子这个 theta 是可以从0带到360度，然后你就可以看到每一个方向的分量。Okay, so another important thing is that, because they are all component, we are talking about component. We are not saying that this point, if you draw this point in with that square, or this point you draw that square, they only has different stress component, but stress status are the same. The only change for you is just the component, but the value of the stress itself are the same. You just rotating the axis, observation axis. So don't think, you draw the stress element direction differently and you change the value of that point. No. The stress at that point status are all the same. Okay? 我的意思就是说，你画这些方格的角度不会影响到当那个点的应力状态，你只是改变你的观测的坐标而已。OK， 你只是画出它的分量是不同的，但实际上当下那一点的 stress 的状态是一模一样的，不会改变的。OK。 So I just draw a figure, okay? This figure is actually just this one. So you see this red one is normal stress and the shear stress is blue one, okay? And you see in the direction theta equal to 0 means that you are talking about the focus is on that surface, and this is 0 degree, and this is sigma x, okay? And for 45 degree, so this one is minus 45 degree, and your focus now is this direction. So this is 45 degree, and this one, sorry, and this one is theta equal to 90 degree. Okay, so at this point, this surface, no normal stress on that surface. Okay, and of course, this one is okay, and 45 degree. We are talking about this surface. Okay, 45 degree, and your stress, normal stress at that surface is this value and that value. Okay, so at that 45 degree, you have normal stress half sigma x, and you have your shear stress negative sigma x. And here, 45 degree, not minus 45, sorry, this should be minus 45 degree, and you will have normal stress equal to half sigma x, and your tau sigma, tau theta equal to half sigma x as well. Okay, so notice that the extreme value, sorry, here and here, they are all 90 degrees apart. 90 degree apart, 90 degree apart, 90 degree blue per curve, 90 degree apart. Okay, and when normal stress is maxima, shear stress equal to 0. But when shear stress maxima, normal stress is not 0. Okay, that's it. So I hope you can understand that materials, when you see the material, the inner stress component can be varied, okay, when you observe different directions. So when you find that some loading and certain direction, they have greatest value of sigma, which means that at that direction, it will break compared to other direction. So that's how you examine which direction of the material will break. 对吧？哈 ，OK， 听得懂啊？哈，就是你用这个分量就看出来哪一个分量上它的应力是最大值。那如果你照这样下去，那边就是会最快坏掉，大概是。所以这就是为什么材料学可以帮助我们去学说哪边容易坏掉。OK， 来 ，nice。Next one. So there is a material, and the material has a force. P90 Kn. Sorry. It should. Okay, now this is not tensile. This is compression. So be careful about this. Okay. And then A equal to 120. Sorry, 1,200. and P equal to 90 kN, and the problem asked us to find the sigma theta, tau theta at theta equal to 25 degree. Okay, so 25 degree, you can see like this, right? So 25 degree, and be careful, be careful. You notice that the direction, this one, the x1 is here, and y1 is here. The x1 and x angle is 25 degree. Okay, so this one. So we want to find the sigma theta and tau theta. Okay, so firstly, we want to have a what's that? We want to write down sigma. Sorry. Hey, sigma x. Sigma x equal to p divided by a. Sigma x is important, right? Because the equation always start from sigma x, right? P divided by a, and this is really important now. 90 times 10 to 3 divided by the area 1.2 times 10 to minus 3 equal to 75 m per. And there's a very important thing is that negative because this is compression. Okay, careful, because our equation we obtained from the previous few pages, we assume positive P, right? This tensile P, but now this is compression P. Be careful about this, minus. So let's take a look. Sigma theta equal to sigma x cosine 2 theta equal to minus 75 cosine 25 degree square equal to minus 61.6 m per. Okay, you obtain minus 61 m dot 6 m per. Okay, then you can have tau theta equal to minus sigma x sine phi cosine phi, just equation, right? Minus 75. Don't forget the minus sign, and sigma x also has its minus sign. So careful about this, right? Sine 25 degree, cosine 25 degree, and it equal to 8.7 m per. Okay, so sigma theta equal to minus 61 blah blah blah, and tau theta to 8.7 m per. Right. So you can see that. Careful. Now, let's draw the direction, all right? Because now here is minus, this is positive, and your focus, the face you focus, the surface you focus, 主角面, your focus is this one, right? So you're minus 61.6 minus, okay? And positive 28.7. Positive. So this is positive. This is positive x1 surface. So your positive shear must go that way. Positive y1 direction. Okay, so need to be really careful. I hope you can understand what I'm talking about. Right. So This is the first problem. Complete states of stress at theta equal to 25 and show the stresses on a properly oriented shear element, stress element. So stress element, which means that you need to plot this square. Okay, you need to plot this square, and with proper shear stress and normal stress on that. So yeah, it's okay. I guess this is okay. You draw this one, and the surface need to have 25-degree direction when you have the exam. Okay, you need to draw this by yourself. Okay, and then the first surface we know that 25-degree, right? Minus 61.6, no problem. And the other is 28.7 MPa, which is positive. We know that, right? So this is the first area that we know that. Okay. However, we need to complete this stress element. We also have this three surfaces need to be completed. So we need to do that further. Okay. Now we are going to draw this surface. All right. For this surface, for face BC, this surface theta equal to what? 25 degree plus 90 degree, 115 degree. So now our focus is now on green surface. And then you need to look at this green surface like this one, this guy, like this guy. I'm drawing a student. Okay? You see what I mean, right? We need to do that to see the green one. Okay? Okay? So鸟山明寺，我好难过。我以前小时候，我的梦想是当个漫画家。没有啦，你看就知道我没有天分啊。Anyway，sigma BC sigma x cosine square 115 degree 啊，怎么会变这样 ？I'm sorry. Yes. Equal to minus 75 cosine 115 degree square minus 3.4 n pa. Okay, and right. So you have sigma BC minus 13.4. So now with your neck like that, you know that 13.4 megapascal is compression. Okay. And then of course you can do tau BC, blah, 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 blah. Okay. But do we need that? Actually, we don't need that because we know that they are come in pair. Dun, 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 dun. That's it. Okay, but we will continue after 10 minutes. If you have any questions, just let me know. Thank you. Okay, welcome back. Welcome back. Let's continue. So, you can imagine that previously, not previously, this direction, you will have x1, y1, right? 25-degree. Your x1 direction has angle between x was 25-degree. Okay, but for the green surface, your direction is this one. Y1, x1. Let me move a bit to make it more obvious. And then you notice that this direction, this angle is 115 degree. Okay, 25 degree and 115 degree, which is theta equal to. Okay, so your focus in the pink surface was 25 degree, and then your focus on green surface was theta equal to 115 degree. And you notice that all we need to do is just calculate sigma BC, normal stress on BC, but we don't need to calculate tau BC. Tau BC. Do we need to calculate that? Actually, we don't need to. Okay, but well, we can check. Okay, we can check. The reason why we don't need to determine tau BC is because we have learned that the shear stress need to be come in pairs, right? Come in pairs. So if you are absolutely sure this one, okay, and then you can directly get this one and that one and that one, right? Previously, we know that we taught you about the grouping of the group of shear stress. So, and then of course, this is minus 61.6, and the other will be the opposite direction. Okay, and if you have this one, you can have that one. So basically, when you determine until here, everything can be plotted. But now we check. Okay, we check. We just study, right? We check if this is correct. Sorry, sigma minus sigma, sine 115 degree cosine 115 degree equal to minus 28.7 m per. Oh, 28.7. 28.7 megapascal. The value is the same, but this is a minus. And it's correct. Is that correct? Is that correct? Yes. Because when you using this head, you see this point, this surface is positive x1 direction surface, but this direction is minus y1 direction. So plus and minus, right? Minus 28.7 m per. And you notice that this is positive if you treat it, this one is main focus, okay? But if you treat this one as main focus, this is minus 28. But they are in the same stress element, okay? So yeah, this is you need to make sure the surface you are talking about is correct. 那么大声呢？刚刚都不会的嘞。Okay, anyway, so I hope you can understand this. So you need to understand what is the minus, but still in the same as stress element, because the observation axis are different. Okay, right. Yeah, that's it. Next one is more difficult. Then the bar. Let you make the note. 刚刚讲到鸟山明是我的偶像。我小时候，如果小学的时候，如果今天叫我写作文，就是我的梦想，我就会说我想要当个漫画家。然后那时候就有买那个鸟山明的漫画教室，那是我小时候的事情，所以你绝对没有看过了哈。那总之就是有漫画是来教你画漫画，然后那时候就是想要画，就发现啊，好难哦，我只能画到一种程度以后，我就发现我没有耐心了。就是有些你知道他们会要那些阴影啊什么那些，其实超难啊，所以我就照着画得很漂亮，然后很可爱很棒，然后但是我不会自己画，然后我也不会画一些那些阴影的那些部分，所以后来我就 发现我好像比较会念书，所以我的职业就变，对，我职业就变成学术方面，对对。At some point you will find out actually what you want may not what you can be. Yes, yeah, at some point. But it was fun to have some heartbeat. OK，然后我们那个年代的小朋友，大部分喜欢画画的人，绝对都有画过孙悟空变超级赛亚人那一幕，应该吧？你知道我在讲什么吗？你知道超级赛亚人是什么吗？对，哇，真的是那时候觉得好帅啊！天天天天都在画那个东西。好了，OK，Anyway，so next one. The bar is connecting by the glue. Glue means 胶水。Okay, the P downward, still compression. Okay, and the bar is constructed have two parts. The full part is connected by glue joint. This is glue joint. You can imagine that this is two pieces and stick it together. The P is 35 kN. Alpha, this one is 40 degree. And okay, sigma P allow. The P allow means that pillar, the pieces, okay, the material has 77.58 megapascal sigma in compression, and tau allow is 4.0, okay, and sigma G means glue, okay, the glue itself cannot handle the compression 5.2 and cannot handle the tau shear stress 3.4 MPa. Okay, so we need to design the minimum width of B. Okay, so this is really interesting thing because you need to focus on two things. The first one is no three things. The first one is the stress element on that glue section. Okay, this is the first one. And the second one is that, well, the force, we need to check also. We need to check if the material itself will be break or not. Okay, so if you want to check, because the glue joint has been set 40 degree, right? So this is set. But for the material, you need to examine that in all direction. So maxima occur in 0 or 180 degrees. So this one need to be checked. And 45 degree also need to be checked. Right? Because maxima occurred in these two cases. So the first check is glue joint, this surface, and the maxima normal and maxima shear. So we need to check these three things, three surfaces. And if we check that, and then we can obtain the minima of the B. Okay. So this is a little bit difficult, yeah, I would say. So the minima B is what we need to determine, right? So we need to get, so the B here is actually related to area. And the area can help us to determine the sigma, right? Sigma X. So now we need to obtain that our calculation will follow from sigma X to B, right? Because this is our answer, right? So we need to determine sigma X. Okay, sigma X. Let me take a look. So, one, sigma X for the glue joint Okay, a 1, okay, the small problem 1. Sigma x, so now, sigma x, the value 5.2 is the sigma glue allowable, right? Equal to sigma x. So this is what we are going to determine, right? So cosine. Okay, this is a little bit, you need to be careful. Is that 40? No, it's minus 50. Why? Let's take a look. So if we put this light down and you can do like this, right? And your force will looks like this one, okay? And this glue section looks like that, and this alpha. Oh, this one is alpha, right? Alpha. So this alpha will tell us this x. So this is x and y, and your new axis is y1, and this is算了 a bit x1, okay, x1 and y1, okay, so your x1 y1 need to be this one, okay, x and y, x and x1 and x, angle should be 90 minus 40, so this is 50, and you see this one with the clockwise, this is not from here, right? It should be here, so this is minus 50. Okay, that's the reason why this is minus 50, not 40. You need to be careful. Okay, so if you can do that, and then again, you need to think about the direction. Okay, you see here, if we are going to decompose this P into Y1 and X1, it will looks like that and that, right? Along X1 and Y1. So this one will be compression. 不能写这个 compression, and this is minus. And this shear, sorry, I should move a little bit. Okay, and here should be shear, but in negative, because this x1 positive surface and downwards negative y1 surface. So this case in the surface minus 50, normal and shear are both negative. Okay, so need to be really careful. So now, of course, it make this one minus 5.2. Okay, so sigma x equal to minus 12.6 megapascal. So, which means that if your sigma x is greater than more negative than 12, 为什么不能 12？哎哎，糟糕啦！蓝牙，为什么？ 哎，怎么会这样？西部 Apple Pencil，这个还忽然断掉啊，太烦了吧？有人可以教我吗？你看，哎，哦，连线，好，OK，OK，OK，good，这种东西还会断，搞什么啊？讯爆了。OK，sorry，so negative，OK，呃，OK，continue. So your sigma x is more negative than minus 12.6, and then it will break. Okay, and then your tau 3.4 equal to minus sigma x sine minus 50 degree cosine 50 degree, and of course again minus because your component is also minus. Okay, this one, dang, this one, dang. Okay, so well equal to sigma x equal to minus 6.9 amp. Okay, so which means that if your sigma x is more negative than minus 6.9, it will have shear failure at glue joint. Okay, I hope I can make it clear. Right, so this is first check for the glue joint, but don't forget, you need to check the material failure also. The material failure is the second one. You need to check the maxima occurred in the material. The first one is maxima normal stress, and maxima shear stress is the second. Okay, so sigma x for the material, not for glue joint. Glue joint is for 40 degree, right? Or minus 50 degree. So again, sigma x cosine 0 degree, right? And this is 7.5, but in compression, right? So you can imagine that this is, right? Right? The pink one. So we can have sigma x equal to minus 7.5 megapascal. Okay. So in the material, if your compression make the sigma x more negative than minus 7.5 megapascal, it will break. The material itself will break. Okay. Again, next one. For the and of course, this is minus sigma x psi 45 degree and cosine 45 degree. This is the where the shear stress, maximum shear stress occurred, right? 45 degree. And what is that? This is 4, right? The 4 here, and then we need to see that this is dun, 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 dun. And we say this is 45 degree, right? And the 45 degree, you can imagine that if you the component shear, the shear here, if imagine that your component here will be this one and that one, right? So your shear here in this will be positive because this is new x1 direction surface, new x1 direction surface, and this direction will be new y1 positive direction. So positive, positive, this one will be positive. Okay, so you need to be really careful about the direction. Difficult, right? Sigma x equal to minus a m pi. Okay, so now we check all this. Dun, 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 dun. We check all this, and then we found that make the material not exceed these 4 value, the sigma x, dana, 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 all found, right? So which one should we take? Do you wanna have a bonus? Which one should we take to take it that? Oh, sorry. To take that to determine the B. Which one? The biggest or the lowest? Which one? Raise your hand. Good. Lowest one. So 6.9, right? Good. Very nice. So we need to choose the lowest one. Choose the lowest. Okay. And so can you give me your number? About English. 110. 610. That's difficult, right? I know that's difficult. 3. Okay. 016. Good, good, good. Very nice. Yeah, I know this is really difficult. When you want to, so for example, when I leave a board and I want to apply for mobile phone packages, and they will ask me the number, and then I always write down everything. I even, okay, also they will ask me my name. I need to write down NIEN, right? For the N, you cannot say MIEN, you should say number India, Elsa number. You know that? Otherwise, they will say, M, T, D. So it's really difficult. So all you need to do is just write down. So for me, when I call the customer service, I need to say, okay, M number, and I India, E Elsa, something like that. Do you know? That's really difficult. And all you need to do is prepare. Okay. Anyway, that's really interesting experience. Right. So choose the lowest. Your B2 equal to A equal to P divided by sigma X. So it will be minus 35 kN divided by minus 6.9 M R. And it will become B equal to 71.2 millimeter. So your area length of your cross section cannot lower than 71.2 millimeter. Otherwise, you may have glue joint shear failure. Okay, glue joint shear failure, because this is the lowest, smallest value you cannot exceed. Next one will be the most difficult one problem in this chapter 2. And because this is the most difficult one, so previously it was in our practice and I didn't bring it up in our lecture note. And all the students, all your seniors asked me, how can I solve this? So I said, okay, I just include it in my teaching materials. So next one will be the most difficult one. Very, very difficult. Okay. Customer service. It's really interesting. When I study in the UK, I spent 4.5 years there, and I applied for a mobile company called Three 三，那个电信公司叫三。And then after 4.5 years, I'm going back to Taiwan for good, forever. Okay, so I need to cancel my mobile phone number in the UK. So I call them. You know, it's really, really difficult to delete my number because they want you to keep that number so they can earn your money. So they will give you many, many difficult tasks to finish, and then you can cancel your number. So very, very difficult. And also, I'm sorry, they tend to use foreigner customer service agent to dealing with you, to talk to you, because they have very serious English accent, and you don't understand what they are talking about, and maybe you will give up. Do you understand what I'm talking about? 就是啊，我之前在英国去弄那个叫什么申请电话的时候，然后回来的时候，我要去 cancel，我要去就是把我的电话停掉嘛，不然他会一直 charge 我钱啊。然后他就一直不让我做这件事情，他困难重重，他就一直叫我说，哎，那你要怎样怎样，你要提供什么什么资料啊，然后证明你是谁啊，而且他就电话讲哦，然后他都用外的人员来跟你讲，例如说不要例如好，这样子有点不太好。总之就是别的国家的人跟你讲话，然后哇那个口音你完全听不懂他讲什么，然后哇很痛苦，然后我跟他讲，然后他也听不懂，然后我们两个这边鸡同鸭讲讲了超久，然后浪费我很多电话钱，然后我打了大概至少也有4、5通，我才成功的把我的电话就是停掉了，对，非常恐怖。对，那个他就故意用那个呃其他国家的啊，我不能讲是哪一个国家，还蛮有趣的。总之就是，即使是我的同学已经是那个国家了，我已经很习惯那个国家的口音咯，但是打电话去那个人，哇，还是超强的，极非常厉害的口音这样，好，就这样。Okay, next one, the most difficult one. Right, problem 2.611. So this plastic bar is a rectangular cross section. Okay, B blah 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 H blah blah blah, and then it has it will fix on the walls, and then at room temperature 20 and no initial stress at beginning, okay? And raise the temperature to 70 degrees C. The compressive stress on an incline is PQ at mean span becomes 8.7 MPa. Okay, and what should I say? Did I miss something? Oh, okay. I guess they have the alpha, 95 times 10 to minus 6 per degree C, and E equal to 2.4 gigapa. Okay, so more information is needed. I give you this one. Okay, right. So this is more information we needed, and if the allowable normal stress in 23 MPa and allowable shear stress is 11.3 MPa. I guess this is. So allowable for the normal stress 23 and shear is 11.3 MPa. What is the maximal load P in X direction? So the X is that, okay? The X is at the quarter of M, okay? And the loading of P in X direction, you see, I highlight that the positive X direction. I highlight that sentence as actually this is a key to solve this problem. Okay, key that one is key. Okay, which can be added at the quarter point in addition to the thermal effects given and without exceeding. Okay, so you can imagine that this bar fix and then rise from 20 to 70 degrees C, 50 degree C increment, and also you will have the force along positive X direction act on quarter of the length, and then we need to determine what P, the maximum P is to not exceed 23 MPa in normal stress and not exceed shear stress in 11.3 MPa. Okay, not break. Okay, so what will it be? This is really difficult because you see this is statically indeterminate system and thermal, and then you also need to do the incline. Whoa, this is kind of mix all the problem you learned from the past few weeks. Right, so let's take a look. How can we solve this? Of course, this is RA, this is RB, right? And we want to see, eventually we need to write down the compatibility equation, right? So the compatibility equation is that there are two sections, the first section and second section, because the status change by this force at that point, right? So you have two pieces, the first one, the two sections, first one and second one. And then we need to know that the second one part deformation and the first and second part deformation summed up together need to become zero because will be zero. Okay, so this is a compatibility equation. So, and also the equilibrium equation. So let's write down the first one, RA plus P plus RB equal to 0. No problem, right? They are all to the right. So that's it. This is equilibrium equation. How about a compatibility equation? Okay, compatibility equation is that there are three types of deformation we need to determine. The first one is the first section and the second section and thermal strength, right? So let's continue. So firstly, we need to write down here RA, and this is N1. Okay, the N1 here, we just assume that is a positive, and then our M1 equal to minus RA. Get it? Right? And N2 okay, this is RA, and don't forget this one with the P. Okay, and this is N2. We don't know, so we just assume positive, and then we will have N2 equal to minus RA minus P. No problem. So this is delta 1. The delta 1, of course, related to N1, right? And delta 2 related to N2. And L delta T alpha equal to 0. So 3 types of deformation. N1, due to N1, the deformation due to N1, deformation due to N2, thermal, okay, thermal. So these 3 types summed up together need to be the same. Need to be no deformation in total. Okay, so this is the first one is equilibrium equation. This is compatibility equation. Okay, and then delta 1, of course, it will be N1 minus RA L quarter divided by EA, the material. And delta 2 equal to minus RA minus P 3 L quarter divided by EA. Okay, right. So yeah, you should say delta 1, and this is delta 2. Okay. Let me save some space. Okay, that's it. So delta 1 and delta 2 and thermal. So now we can substitute that together, and we can have L for EA minus RA minus minus 3RA minus 3P plus L delta T alpha equal to 0, and RA indicate minus 3 4P plus EA delta T alpha equal to minus 3 divided by 4P plus 32.49 km. Okay, so your RA looks like that. Okay. So now we can have RA now. The RA allow us to determine the remaining part of that. We can use RA to check the first part. If the first part exceed the requirement of the first part of the P, okay? So we need to examine each part by each part, okay? Each by each. So the first section, the first section. Okay, so the first section, because N1 plus RA equal to 0, right? So the M1 equal to 34 P minus EA delta T alpha, of course. So your sigma X is easy. It's easy. 3P 4A divided by E delta T alpha. Okay, so you can obtain this by substitute all this. I don't know if this is okay, and it needs to be less than 23 MPa, right? Because 23 MPa is the material cannot exceed that stress, normal stress. So sigma x, and sigma x is the maximum value of the normal stress, right? But the tau max, sigma x is maximum normal stress. But tau max, how about tau max? Tau max is 45 degrees, right? Remember, this is positive or negative sigma x divided by 2, right? So your tau max, tau allowed equal to 11.3 megapascal. So which means that your sigma x equal to 22.6 megapascal. Okay, so you notice that this one is 23 is greater than 22.6. Okay, so which means that actually 23 megapascal is safe. If your sigma x become 22.6, it will firstly shear failure. So you will never normal stress failure because it will shear stress failure first. 现在看得懂我的意思吗？就是说啊，我们看第一个阶段，我们去检验它到底它的它的 sigma x 要多少。那 sigma x 因为它是0跟100嘛，它是最大值，那它就会要至少它一定要小于23 megapascal。OK， 好，所以我写出来了。这等一下要算的时候，我 sigma x 不能大于23 megapascal。OK， 那接下来要去检验最大的检应力值，最大检应力值 tau max 的，我们之前不是带45度吗？45度就是正负的 sigma x 的1半嘛，对不对？好啦，那结果我们的 tau allow 是11.3 megapascal。那我们这样算出来，发现它要求的 sigma x 是22.6 megapascal。那就表示说啊，这个材料在这样子的状况下，如果你其实根本不可能会正向应力的破坏，因为 它还没到23的时候，它就已经先到了22.6了。它先到22.6，它就先简力破坏了，所以它根本不需要到正向应力。所以23 megapascal 这个东西是白写的，你知道吗？所以这个题目这23.3，其实它只是放在那边给你，嘿嘿，就是一个陷阱吧，或者什么之类的。就是其实根本没有用到，它根本不会用到的，因为你22.6就已经会让它的简力破坏了，超过22.6就已经破坏了，根本不需要等到23啊，这样的意思。Okay, so and don't forget this one, positive and negative, because tau maxima will always have the different main focus surfaces. So positive or negative, all possible. Okay, so the first section, we will have the first section, we notice that 22.6 megapascal. Okay, so if you can memorize this and we are ready for the next one. Maybe I don't have time for the next one because we only have 2 minutes. But you can notice that the sigma x can be positive or negative. Okay, because this is positive and negative, right? Positive, negative, positive, negative. So you can starting from this point to determine sigma x. Your sigma x can determine p, and then this is your answer. OK， 好，总之啊哈，你看哦，我们这边的 sigma x 就会有正负22.6 megapascal 嘛，对不对哈？然后 sigma x 又会跟 p 有关，你只要乘到它的 area 就可以了，对不对哈？所以说我们可以得到第一段的 p， 如果那个第一段 p 如果高于那个 p 的话，它第一段就会破坏掉，这样的意思。OK， 所以明天早上我就会开始从这边去算它的该有的 p。应该说不能超过的 p 了哈，不能超过的 p， 到时候就会知道。那因为正负号的关系，会跟这个正 direction 有关系，好，所以明天就会讲到了。Okay, so I will stop here and I will continue our lecture tomorrow. If you have any questions, just come to here and let me know. Thank you. 请问
这个贝塔 P 跟贝塔 G 是在算哪里？
这个嘛 P 就是它的 plastic， 就是 material， 就是它的蓝色的 material， 然后 G 的话就是那个这个面的胶水的强度。
是上面这个，
是这个面上 ，G 就是这个上面上这个叫做 glue joint， 就是胶水的边界啦。
那为什么下面这边还要再算蓝色？
因为我们第一个只在算这个面上的应力元素啊，但是材料自己本身也可能会坏掉哦。
是为什么这边的 x 轴跟 y 轴的方向跟这边的 x 轴跟 y 轴的方向又不太一样？
哪里？
上面这里它的好像 x 是我们 x 轴是这样跟这样，
对，
这边好像就变成这样。
哦，那是因为这个面我把它倒下来看。倒下来看，这个面已经被切到了，所以我就得去看这个面的应力元素。
所以上面这边也是因为
他要求的25，他要求。然后下面这个这也是题目要求的，是在这里
倒下来。
对，
所以是看你的方向。
所以对，应该说题目要求哪个方向，我们就得做哪个方向。OK。好，请问，因为它长度是3/4啊。
所以这个图画的是从这边接续下去。
No，sorry，我可能这个东西只是例图而已。你要这个 N2 是这一段的内力，它一过这条线就变成 N1。那我为什么要画这个？是纯粹只是为了力平衡而已。因为我不是说要看这一段的力，我就把它切一个地方，然后我必须留左边或右边，所以我们留左边，那当然会看到第一段的东西。那我只是为了算这一段的 N 而已，第二段的 N2 而已，所以这边还是3/4L，就是我只看这一段的东西。你为什么看到前面？是因为我留下来了，我必须力平衡。 这样听得懂吗？
啊，所以这里的 N 度是切这里的，
是这一段的。其实这个 N2你要切哪里都可以哦，切这里，切这里，切这里，切这里，切这里都可以哦，都可以哦，都可以哦，都可以哦，都可以哦。但是你不能切这里，因为你已经超过那个 P，你一超过这条线，我们的 P 就不见了，我们的力平衡就会出。但是我的这一段都在讲这段3/4的，OK，
应该吧？应该都是。
听得懂吗？OK 哈，我画这边纯粹只是力平衡而已，但是这个 N2的作用只有在这一段，所以我要切这里，切这里，切这里，切这里，切都可以哦，都可以。反正我切哪里，纯粹只是这边变长变短而已嘛。那你力平衡都是一样啊，这个数字不会变，但是一超过这条线啊，那就不一样，就错了。这样 ，OK？对，真的吗？哪里？哪里？哪里？这里。谢谢你，要不要加个分呢？没关系啊，你不需要吗？来讲写一下。111 613 035，好，谢谢。请问，
小考范围就是1、2章嘛。
对，1、2章，
啊，会每个
对，
就是题目都长差不多这样。
对对，都会差不多。嘿嘿，谢谢谢谢。